All right, this is a fun problem. Chapter 5, problem number 57 reads, Stay dry! You tie a cord to a pail, swing the pail in a vertical circle, kind of like this. I didn't really draw. Here, let me draw a circle for this. There. It's a beautiful circle. That is your motion. Those should be phantom lines, technically. But anyways, in a vertical circle with a radius of 0.6 meters, what minimum speed must you give the pail at the highest point of the circle to avoid spilling the water? So, the water in the pail, the only force acting on the water are going to be the pail when it's pulling it side to side in ways, and gravity constantly pulling it down. Or when you're at the bottom point, the pail is going to be pushing up on the water. But at the top, you need the force pulling on the water and the pail, or the acceleration of them, to be the same. So you need at least the same, which means you must have the force acting on them as mg. So if you're swinging it, you don't need, when the pail with the water is straight up, you don't need to be pulling down on it at all, as long as you have it going the correct speed. So that way, if you're at a constant velocity at the bottom, your tension is going to need to be twice that of mass times gravity if you're keeping things constant. So up here, you have the typical equation for centripetal forces is the tension, or your net force, so to speak, would equal mass times velocity squared divided by r. Well, if we put it at the top, our force pulling it down is just going to be the force of gravity, which is mg. So mg equals mv squared over r. Throw it down here, mass on both sides, get rid of that. G equals v squared over r. So if we take the square root of g times r, we'll get the velocity. So our velocity is 2.43 meters per second. That's a fun problem. I've done that with a bucket of popcorn.